Black holes are among the most mysterious cosmic objects, much studied but not fully understood. These objects aren't really holes. They're huge concentrations of matter packed into very tiny spaces. A black hole is so dense that gravity just beneath its surface, the event horizon, is strong enough that nothing, not even light, can escape. The event horizon isn't a surface like Earth's or even the Sun's. It's a boundary that contains all the matter that makes up the black hole. The event horizon of a black hole is linked to the object's escape velocity. The closer something came to a black hole, the greater the speed it needed to escape. This means a black hole's event horizon is essentially the point of no return. There is much we don't know about black holes, like what matter looks like inside their event horizons. However, there is a lot that scientists do know about black holes. Spaghettification is the real term that describes what happens when matter gets too close to a black hole. It's squeezed horizontally and stretched vertically, resembling a noodle. Stellar black holes are formed when massive stars run out of fuel and explode in supernovae. Most Milky Way-sized galaxies have monster black holes known as the supermassive black holes at their centers. Ours is called as Sagittarius A, pronounced A star, and it's 4 million times the Sun's mass. The most massive black hole ever discovered by mankind is Ton 618. It tips the scales at 66 billion times the Sun's mass. For comparison, our Sun's mass, in kg, is 1.989 followed by 30 zeros. The lightest known black hole is only 3.8 times the Sun's mass. Black holes don't emit or reflect light, making them effectively invisible to telescopes. Black holes can be surrounded by rings of gas and dust, called accretion disks, that emit light across many wavelengths, including X-rays. A supermassive black hole's intense gravity can cause stars to orbit around it in a particular way. Astronomers tracked the orbits of several stars near the center of the Milky Way to prove it houses a supermassive black hole, a discovery that won the 2020 Nobel Prize. When very massive objects accelerate through space, they create ripples in the fabric of spacetime called gravitational waves. Scientists can detect some of these by the ripples effect on detectors. Massive objects like black holes can bend and distort light from more distant objects. This effect, called gravitational lensing, can be used to find isolated black holes that are otherwise invisible. In black holes of all sizes, something strange can occur near the inner edge of the accretion disk. A small amount of material heading toward the black hole may suddenly become rerouted into a pair of jets that blast away from it in opposite directions. These jets fire out particles at close to the speed of light, but astronomers don't fully understand how they work. The jets from supermassive black holes, the type found in the centers of most big galaxies, can reach lengths of hundreds of thousands of light years. General relativity predicts that the very center of a black hole contains a point known as the singularity, where matter is crushed to infinite density. It's the final destination for anything falling into the event horizon. The singularity may be either a physical structure or a purely mathematical one, but right now astronomers don't know which is true. The prediction of a singularity may signal the limits of relativity, where quantum effects not included in the theory become important in a more complete description of gravity. Hawking radiation is the radiation theoretically emitted from just outside the event horizon of a black hole. Stephen W. Hawking proposed in 1974 that subatomic particle pairs, that is photons and neutrinos and some massive particles arising naturally near the event horizon, may result in one particle escaping the vicinity of the black hole while the other particle of negative energy disappears into it. The flow of particles of negative energy into the black hole reduces its mass until it disappears completely in a final burst of radiation. Space adventure.